Installing power factor correction equipment requires a detailed review of the installation procedures and fine-tuning of the capacitor placement and wiring for the CT. Did you know that most power factor correction equipment gets installed wrong the first time and has to be adjusted prior to startup and commissioning? In this episode of The Power Grid, we're going to discuss capacitor bank installation and programming. Hello, and welcome back to The Power Grid, a podcast to help you build reliability in your electrical system and give you confidence in your power. I'm Brian Brannigan with Power Protection Products. We have been solving power quality problems for almost 30 years. We are your trusted advisor for critical power, cooling, and energy solutions. Power factor correction capacitor banks are one of the electrical infrastructure items that often get overlooked and have to be installed by your local contractor. Unfortunately, most local contractors do not have a lot of experience in installing capacitor banks, and this can lead to installation errors that can be costly to the end user. There's a 50-50 chance of seeing a correct installation at startup based on our commissioning experience. Placement and programming of the CTs is critical in order to get the capacitor banks to function correctly. One common installation error is the CT. The CT is monitoring the required kVAR that needs to be injected into the system, so it must be placed above the point of kVAR injection, upstream of the capacitor bank connections. The CT should also be sized correctly and scaled correctly in the program software. Not too long ago, we were working on a capacitor bank job in Amarillo, Texas. Now, if you've ever been to Amarillo, Texas, you'll know that there isn't much around Amarillo. There aren't a lot of resources around there to rely on. But we had a local contractor working on installing a capacitor bank for a grain elevator. And during the installation process, they took a shortcut, and instead of wiring the capacitors to the utility feed, they wired the capacitors to a junction box. And that was fine, but when it came time to installing the CT, which regulates the injection of kVAR into the system, they put it downstream of the main utility feed, and so the capacitor bank couldn't recognize what was actually needed for kVAR because it was supplying kVAR based on where they put the CT equipment. And that's why today we have Andy Angrick from Power Protection Products joining us to talk about capacitor bank installation. So Andy, you have installed more capacitor banks than probably anybody else in the country. What are the chances of a capacitor startup going right the very first time if a contractor is installing the capacitor bank?
Well, that's a fair statement and question. Probably not very good, because there's several factors that come into the installation requirements of a capacitor bank. And if they're not at all familiar or haven't been down that path before, there's generally going to be things that are missed or misunderstood that don't allow it to be a successful installation.
And that's why we're going to be talking about capacitor bank installation today. And I know that you have probably seen more than your fair share of capacitor bank startups that didn't go as well as they could have gone.
Yes, most definitely.
Okay, so let's first start off with this process of buying a capacitor and figuring out where we're going to put it.
Okay.
So the placement of the capacitor bank is pretty critical in the whole decision process. What are some of the items we should be concerned about?
Yeah, so those are great initial questions. Placement, the physical aspect, is it going to be indoors in a safe electrical room, or is it going to be outdoors where we have to worry and be concerned of elements, sunlight, dust, other things that it may impact the operation of the capacitor banks? Yes.
Mm-hmm. So if we decide to put the capacitor bank outside, what are some of the things that we should also take into account?
So, I mean, no matter where you're at geographically, at some point you're going to have sunlight, generally speaking, to contend with. So that's going to be a pretty important and critical aspect.
Mm-hmm. So we need some sort of sunshade over the capacitor bank?
Yeah, and over the course of time, just from our experience in dealing with these, that it used to be kind of a thought. Now it's become more of a highly recommended practice to consider.
Okay, and then they also come in different enclosure types, right?
Yeah, I mean, the standard is a NEMA 1, which is an indoor application, but then there's also the option for the NEMA 3R outdoor rated enclosure.
So once we figure out whether we want to put it inside or outside and what type of enclosure we want to use for that, what's the next item of consideration?
So then it comes into play, okay, where are we physically going to be, like electrically tying in? If it's going to be sitting outdoors, is it running all the way back to, electric room and tying in parallel to the gear there? Or are we tying it directly to the secondary side of a utility transformer per se?
I see.
Yeah.
Yeah. So, and we determine that we're going to need some sort of a breaker, right, for safety.
Yeah, a breaker or the overcurrent protection device could be fused for for that matter, but and there are requirements that you have to adhere to there. So it has to be sized appropriately for the capacitor bank that you're using and then fall within the requirements of the NEC, which is 135% rated.
Okay, so we need a 135% rated breaker to feed the capacitor bank.
Correct.
And this could either be purchased by the installing contractor or we can order that as an option from the factory.
Yeah, and actually that also kind of curtails into, is it going to be a standalone? Is it something that's going to feed the capacitor bank? And if that's not applicable, maybe it becomes an option where it's integrated into the capacitor bank.
I see. And this 135% sized breaker we're talking about a 100% rated breaker, right?
Yeah, correct. So there's that's a very important point to make here, because when, say, for instance, you need a 1200 amp breaker as an example, but if it's only an 80% rated breaker, well, then we can't fulfill all the way up to those 1200 amps, although that may be what's required to adhere to the NEC.
Okay, good. So now that we have our placement figured out, our feeder breaker design figured out, what would be the next step that we'd want to do with the equipment once it's sitting on site?
So then you have to, some of the other things coming into play, if it's going to be going on to some kind of maintenance pad, and that applies even in electric rooms. Oftentimes you'll see the gear that's, floor mounted, but it sits up raised on some kind of concrete or some kind of platform.
Right.
So there's some of those considerations. And then also if you have other equipment or walls to contend with, then you have clearance requirements as well.
Yes. Yeah.
Which are very important.
And then what about actually checking the componentry itself? Because I know this ships across the country through different climate zones on different types of trucks. What do we usually have to be concerned with inside the cabinet once it's sitting on site?
Yeah, and this is a very important point that I'm glad you've brought up, because as it travels from where it's manufactured to its final destination and the road bumps that it incurs, there are several hundreds to, depending on the solution, maybe thousands of connections, electrical connections, mind you, that are very critical. And whenever you have a termination point, vibration and climate change of when it gets hot and cold, expansion, contraction, obviously can impact those terminations and connections. So it's very critical that all of those are torqued to the factory specifications. And that requires a lot of tools too, by the way.
I've seen you pull up with a huge tool bag full of tools.
Yeah, there's, and it's not just your common run-of-the-mill tools either.
Right.
They're very specific torquing tools, screwdrivers, and wrenches.
Right. So the instructions have the torque values written in them, and you just need to have the tools that can torque them down to back to the factory settings after transportation.
Yes, that is
right?
correct. Yeah.
So once we've kind of placed the cabinet and we've wired to the cabinet, we've checked the componentry of the cabinets. Now we have to install something that we don't really deal with very often, and that's called a CT, or a current transformer. Can you tell us a little bit about that?
Sure. So yeah, a current transformer, essentially what it's doing is measuring a primary current, and then it's giving you a secondary output that's more usable to like low voltage controllers and meters and things of that nature. And they take that signal or that measurement, if you will, and then it gets extrapolated into math. So if your primary tapping is 3,000 amps, and it's a secondary of a 5 amps, so there's a ratio factor that is based on those primary and secondary values, and that ratio gets inputted into the controller, and now the controller can mathematically calculate what those true values are.
So if you get that ratio wrong, your capacitor bank isn't going to work up to speed, right?
Yeah, it's not going to perform as expected because its values that it's interpreting and calculating are incorrect. Furthermore, even when you physically install the CT, how it's tapped, and what I mean by that is where you land the wires. Because it needs to be tapped based on the size of the amperage of the service that you're installing into. And that's an important critical factor where, past jobs we've seen where for some unknown reasons, they've tapped it based on the feeder breaker size, not the size of the main service per se. And what that has done is created to where we had to have another shutdown so they could physically go back into the gear and retap it correctly.
Because these are usually on the service entrance live gear.
Yeah.
So in terms of terminating the wires to the CT and determining the correct ratio to be programmed into the capacitor bank, the direction of that CT also could be an issue.
Correct. Yeah, they are directional CTs. They're very clearly indicated with, obvious labeling, but if it's ignored or you're unaware that that's an important factor that, instruction needs to be followed, then ultimately you're inverting the CT essentially. So now its direction of flow, it's going to calculate wrong. Through the course of time, because this is unfortunately a common mistake made, oftentimes the controllers have the ability to where you can correct to overcome those issues.
Because you'll see minus signs on some of the values, and you'll know that that's not the case.
Correct.
So your CT's facing the wrong direction, basically.
Yeah. Yep, because they are directional.
Now, we also have to land the wires inside the capacitor bank cabinet for the CTs. And there's this thing called a shorting block or a shorting pin related to the CT wiring. Can you talk a little bit about what has to happen with that?
Yeah, sure. So then those secondary wires that come from the CT have to land in the cabinet, and there's a shorting pin there. So it gives you the ability, if you've made a mistake potentially, that you can reshort that out, make a change on the secondary side of that shorting block, and then, without taking an outage and going back into the gear to where you can correct that wrong.
Okay. So after we have terminated the wires on the CT correctly, and we have put the CT on the electrical service in the correct direction, and we've landed the wires back into the capacitor bank, into the shorting block terminals, I think then we pretty much have everything ready to go, right, for installation?
Yeah, so all of the physical wiring and the installation's been completed more or less at that point. But then before you begin the actual startup process, there are some checks and balances to make sure that everything done was correctly. Yes. And some of that could be is making sure that all of the phasing coming to the capacitor bank was done appropriately, and just some of those off the checklist type stuff that needs to be verified.
So we have to go through a certain amount of programming right, for the controller for the capacitor bank. And I guess that probably starts with like a password, right?
Yeah, there is a password that's required in most of all of the controllers that we encounter, especially the brands that we're specific to.
Mm-hmm.
And there is a process that is definitely required to make sure the capacitor bank is going to function appropriately.
Yeah, because these capacitor banks and these controllers are built to go all around the world. So we probably need to take some time to tell it that we're dealing with a 480 volt system,
Mm-hmm.
right? What the CT ratio should be, and what are some of the other items that you have to program into the functionality of the software?
So great question. And there's quite a few points, but a lot of those, the factory default settings adhere to the vast majority, but some in specifics, what is the target power factor setting that you're looking to achieve?
Mm-hmm.
In some instances, a capacitor bank might have been sized based on trying to achieve unity power factor.
Right.
So obviously we would have to change that target setting to accommodate that requirement.
Mm-hmm. Okay. And now we have our program correct. We think our capacitor bank is ready to go. Before we start it, what are some of the safeguards that you usually go through before actually energizing a capacitor bank?
Yeah, and that kind of blends into what I was saying just a moment ago, is that making sure that the phasing is correct. I mean, oftentimes the contractor using phase-colored conductors, but not all the times. And if they're phase taped, as an example, if that process was done incorrectly or they didn't ohm them out to make sure,
Mm-hmm.
those are some things that we check on our end before they actually energize the unit, as an example.
Okay. Anything else that you might check before you energize the unit?
I guess more or less just making sure that everything else appears to be done correctly, and that they did adhere to the clearance requirements, that the breaker that's feeding this, not only is it sized correctly, but oftentimes breaker have settings and dials.
Yeah.
And I've encountered this over the course of time to where if you go to turn it on, the breaker setting is too low, it trips.
Oh, yeah.
So there's some of those, preliminary type things just to check off the list.
Okay. And then we're ready to start it up and watch it run, huh?
Yeah, it's probably not as just easy as that, but as going through the process to make sure, when you hit the go button, there could be nothing happens. And then we realize, the door switch was somehow during installation process was bent in, and now we don't, and then you don't have control voltage when that. So there's just little nuances of things as you've done as many as we have over the course of time that when they're all finally compiled and ready to go when you hit the go button, then yes, it's just a matter of going through the function tests.
Okay.
To make sure that everything works as it should.
Thank you for joining us today on the Power Grid. Capacitor bank installation, placement, and sizing can be a difficult task, but P3 is here to help you customize a solution that will meet your needs. Learn more by checking out the podcast notes or going to p3-inc.com.